All right, let's go ahead and get started talking about Wi-Fi 7. So we'll start by talking a little bit about Wi-Fi 7 itself, also known as 802.11be. So what we've seen here in recent years is a really quick run up in changes between different wireless technologies. Wi-Fi 5, aka 11AC, had been around for a really long time before we got 6. Very shortly, just within 2 years of the launch of 6, we got 6E, and now we have Wi-Fi 7. So Wi-Fi 7 is expected to be around for quite a while. Sort of the pace of things here is finally slowed down. And basically, Wi-Fi 7 builds on top of 6 and 6E to expand Wi-Fi 7 support for a lot of these more advanced features. Now, one of the key benefits of Wi-Fi 7 and Wi-Fi 6E as well is the addition of support for the 6 gigahertz space. So traditionally, Wi-Fi has only been allowed to be used in the 2.4 and 5 gigahertz spectrums. So these are unlicensed spectrums, meaning basically anybody can build a device that operates in these frequencies, provided they follow certain rules put down in place by the FCC. So recently, the FCC opened up 6 gigahertz for us to be able to use. And the primary benefit of 6 gigahertz is it's a massive amount of spectrum. So as you can see on this visual representation there, 6 gigahertz provides more bandwidth than 2.4 and 5 gigahertz combined. So more bandwidth means you can have more devices operating in the 6 gigahertz space before you start running into interference issues, unlike Wi-Fi before with 2.4 and 5 gigahertz. So just to give you an idea here, in the US, 2.4 gigahertz had a maximum of about 60 megahertz of channel space that has to be shared by all 2.4 gigahertz users. But the faster speeds we see with Wi-Fi are in large part due to using bigger channels. So with 11AC, we had 80 megahertz and 160 megahertz channels. So just one channel being used by one device is more than the total amount of bandwidth that was available in 2.4. So 6 gigahertz expands that for us. So with 5 gigahertz, we only had two 160 megahertz channels that were available. We now have 7 non-overlapping, non-interfering 160 megahertz channels. So before with 5 gigahertz, as soon as you had 3 APs, if you were trying to use 160 megahertz channels, you would have overlap and interference, degrading the quality of the connection. With 6 gigahertz, now you can have 7 devices all operating on different channels with no interference. It's not until you get to 8 that you start running into issues. So it's very beneficial for those dense deployments. It's going to be very helpful for those that are in, apartment buildings, condos. It's going to be great in office buildings where you've got a lot of different tenants all trying to, battle each other for the available RF space. The other benefit of this wireless, having so much wireless spectrum available, is with Wi-Fi 7 now, we support up to 320 megahertz channels. So you've essentially doubled the speed by doubling the bandwidth that one device can broadcast on at a time. Now, the trade-off with 6 gigahertz is a couple fold here for you. The first one is just like 5 gigahertz has lower coverage than 2.4, 6 gigahertz will also have lower range than 5 gigahertz. And that's just because as radio frequency goes up, the distance the signal can go goes down. So if you're upgrading a customer right now who has 5 gigahertz and they want to have that same coverage in a 6 gigahertz network, you are probably going to need to add some new APs and possibly reposition the existing APs to get that same 100% coverage that you're getting currently with 5 gigahertz. The other challenge with 6 gigahertz is 6 gigahertz is an indoor technology primarily. If you want to use 6 gigahertz outdoors, you have to play nicely with existing users who have purchased licenses to use 6 gigahertz. So to do that, you have to use special access points that are purpose-built for being used outside. And those access points have to talk to a third-party service that tracks and monitors the use of 6 gigahertz outdoor by licensed users and then have your access point automatically change channels or reduce power output based on the current RF environment and current licensed 6 gigahertz users. So it's not as easy as 2.4 and 5 gigahertz devices where you just stuck your your access point outside and you were good to go. So just keep that in mind. All of the products that currently Zyxel is offering are indoor use only that support 6 gigahertz. We will have additional products designed for outdoors at some point in the future, but nothing that we can talk about today. So Wi-Fi 7 um, is built on top of Wi-Fi 6. It basically Wi-Fi 6 and 6E were kind of a testing ground for some newer technologies. They were able to take that knowledge and parlay that into Wi-Fi 7, which should be our main standard for wireless usage going forward. Now, one of the nice things about Wi-Fi 7 is it works across all three radio bands, 2.4, 5, and 6 gigahertz. It's not like 11AC, where 11AC was only on the 5 gigahertz radio and the 2.4 gigahertz radio continued to operate as 11N. So on a Wi-Fi 7 access point, all three radios should be operating as Wi-Fi 7, taking advantages of changes in protocol and behavior to be able to get better performance and better speed even on those older 2.4 and 5 gigahertz channels. Um, the primary idea behind Wi-Fi 7 is improvements to help with dense RF environments, more so than just the changes in being able to operate in 6 gigahertz. There are some additional technologies there that help try to reduce interference between neighboring APs on the 2.4 and 5 gigahertz channel so they can sort of interoperate with each other a little bit better than with Wi-Fi 6 and older technologies. We've got a new type of QAM encoding, so it went from 1024-bit QAM to 4096-bit QAM, so that gives us about a 20% data rate increase, provided you are close enough to the access point to be able to get that higher level of QAM. As we mentioned earlier, we've doubled the bandwidth on the 6 gigahertz channels, and we have something now called MLO, multi-link operation, which allows client devices to simultaneously connect to multiple radios on the same access point. So traditionally, your client device, even if your access point supported 2.4 and 5 and your client device supports 2.4 and 5, it was only able to make a connection on one of those radios at a time, 2.4 or 5. So with MLO now, you can connect simultaneously on two or more radios between your client device and your access point. So that gives lower latency, higher aggregated bandwidth. Um, but the trade-off is there are very few devices today that support it. And what types of MLO are supported vary considerably between those devices. So it's something that's really cool. It's going to be really beneficial as we go forward. But at this point, it's going to be very rare that you're going to have client devices that can take advantage of it. Another technology we have here is something called multi-RU puncturing. So one of the problems we had with 5 gigahertz is you would try to use these 160 megahertz channels, but there were only two available. And if you were sharing RF spectrum and 5 gigahertz with neighbors, maybe they were using a 40 megahertz channel, it would overlap with your 160 and can cause interference. So one of the cool things that Wi-Fi 7 can do is it can basically create a gap in its channel utilization for those neighboring interfering signals. So instead of getting, unpredictable RF interference, you simply reduce your available channel bandwidth by whatever the interference is using and skip that area. So you get slower speeds up front, but it's reliable speeds without the interference issues, drop packets and stuff like that. So overall performance is much better quality for you. So we'll go on here and start talking about our Wi-Fi 7 access points. We have three Wi-Fi 7 access points available. We have at the lower end, the NWA 130BE. Now, traditionally, for those of you that are Zyxel partners, the partner program discounts don't normally apply to the NWA access points. So we have made an exception for that on the NWA 130BE. So if you are a Zyxel partner, you will get your full partner discount on the NWA 130BE. We have the WBE 530, which launched this summer, and then we still have our first flagship Wi-Fi 7 access point, the WBE 660S. So all of our access points use something that we call RF first by design. And the idea behind this is to try to maximize performance of all of our access points. So one of the things we do a little bit differently than some of our competitors is we add in interference filtering for 4G and 5G signals from the mobile operators network. So you say, well, why do I care about that? Why would I want that? And it has to do with the fact that 4G LTE and 5 gigahertz signals often border next to existing Wi-Fi channel signals, and they can have bleed over, which causes interference to the Wi-Fi users. Now, if you're using Wi-Fi in your home, this isn't something you're likely to experience unless your house is, directly next to a cellular tower. But it is something that often crops up in office buildings, larger hotels, larger condo or apartment buildings. So the problem you have with 4G and 5G signals is they often don't penetrate very far into a building. I'm sure we've all been in that situation where if you stand next to the window in an office building, you get a good signal. You walk a couple of cubicles in, and suddenly you have no signal. Um, so the way this is usually solved, especially in newer buildings, is they use what's called a DAS system, DAS, and it takes the cellular signal from outdoors and then rebroadcasts it inside the building. So basically, you've got what look like wireless or Wi-Fi access points, but they're actually kind of like cellular access points. And oftentimes the cable drops for those are the same cable drops that are being used for the standard Wi-Fi access points. So you end up with Wi-Fi access points very close to 5G or 3G DAS distribution boxes inside the building, and that can cause interference. So that filtering helps us in that environment. The other thing that we do that's very different, even from compared to our more expensive competitors, is that our antennas are not mounted on the main PCBA. We have a second PCBA that is separated and shielded from the main PCBA, and that's where we mount our antennas onto. So that creates better isolation between the access point antennas and any sort of EMI issues that may crop up on the main board. It's not going to make a lot of difference if you have a good strong signal, but it can make a huge difference on those edge case, those users that are, operating right at the edge of coverage area, and can make a much more reliable, much more happy user than if you didn't have that isolation. So we'll start here by talking about the NWA 130BE. This is a tri-radio, tri-band access point. So it's broadcasting and serving users on all three radios simultaneously. This is what they call a BE 11,000 class device. So the wireless signal aggregated between all three radios is capable of a data rate of up to 11 gigabits per second. And that, of course, includes all of your wireless overhead and protocol overhead. So it's a 2x2 signal on all three radios. It is a Nebula Flex device, so this can be used standalone, or you can manage it using our free Nebula Flex cloud operating platform. And it has I believe it's a 5 gigahertz uplink port. My bad, I took it off the slide here. Okay, we'll come up to it. It's on a future slide. It's a 2.5 gig. Then we have the WBE 530. It is basically identical hardware to the NWA 130. It's just a W series access point, and we'll talk about what that W series gets you that's not on the NWA in just a few slides here going forward. So when you look at the back side of the NWA 130BE and the WBE 530, there are two Ethernet ports there for you. So one is your uplink port, which you're connecting back to your local network, and that's what provides both the data signal to the access point and PoE power to the access point. So it's a 2.5 gig uplink port, so you can get multi-gig back to your switch to help support those faster wireless speeds. And then we also have a second 2.5 gig port, which can act basically as a switch port out of the access point. So you can just run one cable drop to the access point and then continue with the second cable drop from that access point to another device or another port in that room. And this uses, if you've been selling Zyxel access points, this uses the same type of mounting bracket that all of our current access points have been using here. It's a snap-in plastic mounting bracket that's designed to be able to be mounted to a wall, to a ceiling, to an outlet box, to a junction box. So both rectangular and square and circle. So all sorts of different mounting options are available by default with the bundled mounting bracket. And then you can also buy our optional T-bar mounting adapters, which connect to the T-bar brackets on a drop ceiling, and then those connect directly to this mounting bracket here. And then the access point itself just snaps into that, locking it in place without a screwdriver or other device to slip behind and release it. And then our flagship process or access point here is the WBE 660S. So this guy here is our heavy duty Wi-Fi 7 access point. It's the first one we launched. It is a 4x4 on all three radios, capable of wireless data rates up to BE 22,000. So over 20 gigabits of wireless data handling is possible here. And then it adds some other cool features here. So one of those cool features is this is a smart antenna access point. So our smart antenna technology, instead of using a fixed antenna pattern, traditional antenna for the access point, we have an antenna array that's capable of hundreds of different antenna patterns. So it will automatically optimize the antenna pattern for each connected individual client device. This access point also has built-in Bluetooth BLE, so it basically uses beacon technology, which can be tied in to apps or various other services that you offer in the physical space, above and beyond just what Wi-Fi is capable of there for you. Now, this guy here, because it's so powerful, right, it's having to handle 20 gigabits of traffic on the wireless side, as well as bridging that traffic back and forth between the LAN to the wireless LAN. It does require more PoE power than a traditional PoE plus PoE switch can support. So this does require what we call PoE plus plus or 802.3 BT, the 60 watt PoE standard, in order to power this up. So if you don't have that right now, you may need to buy a power injector or upgrade your switches to provide the higher power output. Or optionally, this can be powered using a USB-C PD power supply. So as long as that USB-C charger can support up to 45 watts of power, you can use those to provide power to the access point itself. Now, because of the faster speeds than on the NWA 130 and WBE 530, this has a 10 gig uplink port. So you can provide quite a bit of throughput between the wireless side and your LAN side, provided your switches support 10 gig links. And then the design itself is a little bit different than our other access points. So what you will see here is the back plate, instead of being plastic like on most of our additional access points, is actually metal. So this is doubling as both an anti-noise RF shield, but also as a heat sink to help dissipate the heat that's being produced off of the components inside here. So we've done that so we can still offer that same lifetime warranty, but we've had to modify the housing in order to be able to handle the extra heat. And so because of that, it's a slightly modified version of our traditional mounting bracket to get around the additional weight and the additional heat being put out through that heat sink. So that's it as far as our access point goes. I want to take a couple slides here, talk briefly about smart antenna, and then we will also talk about the differences between the three access points. So our smart antenna technology, for those of you that have used Ruckus's BeamFlex Plus, it's a very similar technology. And as I mentioned earlier, the main thing here is it uses an antenna array instead of a fixed antenna pattern. This increases capacity of the access point itself. It can handle more users simultaneously before you start running into airtime issues. It reduces interference, both between this and other access points in the area, as well as other sources of RF interference. And it helps boost the general range that the access point itself is covering. So your traditional access point just has one fixed antenna pattern. They're usually optimized for ceiling mount with the assumption that you're mounting the access point directly over the area to be covered. And then it sort of relays out the signal downwards after that. So with smart antenna technology, we have this array, and we're able to, in essentially real time, choose different antenna patterns based on where the client device that we're currently communicating with is in relationship to the access point. And then our algorithm also takes into account sources of RF interference or other devices broadcasting on the same channel that our access point is. So it's able to optimize the antenna pattern that we're using based on those two factors. And because of that, in an environment where you have multiple APs sharing the same channel, we can actually get above 100% airtime utilization. We can get up into the 130s versus most traditional APs where in a multi-AP environment, you're maxing out somewhere between 90 and 97. So we can actually exceed the theoretical maximum because the smart antenna technology allows multiple devices to use that same channel without stepping on each other's toes, or at least reducing how much they're stepping on each other's toes. All three of these access points do support Nebula. So Nebula, for those that aren't familiar with it, it's a cloud-hosted management platform for our access points, our switches, our security routers, etc. It's free to use, gives you access to manage an unlimited number of customers, an unlimited number of sites, and an unlimited number of devices. So now here's a little comparison of the three models. So again, the main one here where we're focused on the differences is the difference between the NWA 130BE and the WBE 530. So again, hardware-wise, they're essentially the same, but the software load is different. I think also the memory may be a little bit different between the two. So the NWA 130BE is a Nebula Flex product. So it is operating as either standalone or managed through the cloud. The WBE 530 being a W series product, it is going to also be able to be managed by the local controller that is built into our USG Flex and ATP series security routers. So if you're looking for a product to be managed locally through a local controller, the W series and the WBE 530 is there for you. This is also a Nebula Flex Pro product, so it comes bundled with a 1-year Nebula Pro license. So Pro Pack is an optional license that's available as part of our Nebula Cloud platform that unlocks some additional features, primarily aimed at those of you that are an MSP or those of you looking for extra services to help with troubleshooting logs and things like that. The other differences here is the WBE 530 offers support for collaborative detection and response, basically allowing the access point to coordinate with a USG Flex series security gateway to provide additional network security on the local network, and also offers support for secure Wi-Fi, which is our ability to basically give you a cloud managed convert the access point into a cloud managed VPN appliance for those of you looking to provide VPN support for remote users back to the main corporate office. And then on the high end here, we have the WBE 660S. It's basically double the wireless speed of the NWA 130 and WBE 530. It adds a faster LAN uplink port because of those faster speeds, and it offers all the same services that the WBE 530 does, and then also adds in support for that Bluetooth beacon technology that I was mentioning earlier. So those are the three access points that we have available. These two guys here are sub $200. This guy here is sub $500. And then lastly here, we want to talk a little bit about Wi-Fi 7 and applications where you may want to add Wi-Fi 7 or where Wi-Fi 7 basically shines. So this right here is going to be high density locations, whether we're referring to high density meaning lots of access points or high density referring to lots of users. Either or are going to benefit from Wi-Fi 7, both because of the use of 6 gigahertz technology, but also because some of the other technologies that are part of Wi-Fi 7 that help better deal with crowded environments than what's currently supported with Wi-Fi 6 and older access point technologies. Another really cool area where I think Wi-Fi 7 is going to shine is when it comes to using enterprise grade mesh for deployments. So you may remember years and years ago, a certain vendor who won't be named really tried to push the idea of using mesh in business environments as a way so you could reduce the number of Ethernet drops. You would simply do like a home smart mesh and just add nodes or extenders, plug them in, and they would connect and work. And it didn't really work that well in a business environment. It works okay in a home environment. In some cases, it works as great in a home environment, but in that dense business environment where you're doing a lot of voice calls and things like that, it just never really worked that well. Wi-Fi 7 kind of solves that. Basically, you've got your 2.4 and your 5 gigahertz radios for all of your client devices, and then you've got this giant fast 6 gigahertz radio that can be used to create the mesh network on the back end. So it's not going to have to worry about sharing that 5 gigahertz bandwidth both between wireless users and the smart mesh links between the access points. By having a dedicated 6 gigahertz radio handling the mesh side of things, it reduces the packet drops, latency, and jitter issues that you traditionally run into with a business class mesh network operating using 5 gigahertz radios. And then, of course, the other area, probably the more obvious solutions here, is if you're trying to send lots of high bandwidth data, or low latency data, Wi-Fi 7 shines here just because of those faster speeds. One of the challenges with real-time video, particularly at higher resolutions, is the bandwidth being used is higher than Wi-Fi links traditionally support, right? Uncompressed HDMI, I think just 1080p, maybe 4K, uses over 4 gigabits of data. So what you have to do is you have to take the video, compress the video, send it, decompress the video, display it, which adds latency. So with 6 gigahertz now, right, we're talking wireless speeds up to 20 gigabits. We're talking a wired uplink port of 10 gigabits. So you're able to push through this high bandwidth applications without needing to do any sort of compression on either end, reducing the latency or improving the quality of data or video that you can push over those links before you start running into issues. And with that, everyone, that is the end of today's webinar. It's just a nice, simple overview here for you. If you have questions, again, use the question and answer part of the Zoom interface to send those in. At least on my interface, it's under the More menu. Or you can send them in using chat. While we wait to see if anyone has any questions, I do want to point out here, most of our webinars are recorded, and we do upload them to be watched at any time through our YouTube channel. Now, because Zyxel is a multinational corporation, and there are a lot of different regional Zyxel channels. So the one here for North America is called Zyxel America channel, all one word. So you'll find replays of our webinars, you will find video case studies, best practices videos, advertisements for new products, stuff like that. So check it out if you have some time, or if you've missed a webinar we had in the past and you wish you could have seen it, you can always usually find it on our YouTube channel, usually within a day or two of when it was originally done. And then if you'd like to connect to us on LinkedIn, we are there as Zyxel US channel. I didn't get any questions coming in, so I am going to go ahead and end today's webinar. Thank you for joining us today. I hope to see you at one of our future webinars. And if you do have any questions that come up or think about later, just reach out to your salesperson, David, Andy, or Jacob, and they'll be able to get the answers for you. Thank you.